Unit 8, Resource Issues. Last unit of Human Geography B. Content Objective 8.1. Explain the reasons why resources are being depleted. Content Objective 8.2. Explain the various ways that humans impact their environment. The ICANN statements for Content Objective 8.1 explain the reasons why resources are being depleted. 1. Define renewable and non-renewable energy. 2. Explain the distribution on non-renewable energy globally. 3. Describe mineral resources, such as A. Metallic or non-metallic resources, or B. Non-ferrous and ferrous resources. 4. Explain forms of land, air, and water pollution. Energy resources. Half is consumed by MDCs, half is consumed by LDCs. But remember, MDCs have a third of the population. They consume 3 times more per capita. Renewable energy. It's unlimited supply. Examples of unlimited renewable energy would be hydroelectric energy. That's the oldest form of renewable energy, usually dams or involve water. Geothermal, heat from the inner layers of the earth. Fusion, which is a form of nuclear energy. Wind, and then solar. Non-renewable energy, they form slowly over many generations, thousands of years. They're old fossils from prehistoric organic matter, animals, humans, known as fossil fuels. There's proven reserves, meaning we know they exist, that they've been discovered and they're usable currently. And there's potential reserves. There's the possibility of using them as non-renewable energy. There's uneven distribution of non-renewable energy because OPEC is a cartel of oil-producing countries. They control a lot of the movement of oil globally. We can look at the energy consumption. Energy consumption in 2007, but the same would hold true today. The most energy consumption is the United States, followed by Canada, and the fastest growing would be China. When we look at both renewable and non-renewable energy, let's take a look at renewable energy such as hydropower, geothermal, and other. We can see that it has grown in terms of quad BTUs, so that's a measurement of energy. From 1920 to today in 2000. We can look at nuclear energy. That's neither non-renewable or renewable because it's known as an alternative form of energy. We've seen the growth of that since the 1970s. And then we look at our non-renewable energy sources. Petroleum, the largest consumed. Natural gas, the second largest consumed. And then we see coal. And we look at both natural and gas. Coal has not grown as much as natural gas, but petroleum has grown considerably compared to natural gas and coal since from 1930s to past 2000s. We can take a look at existing capacities. That has diminished from 2010, and projections into 2030 will continue to diminish. We'll see new discoveries will account for some of the lost existing capacity or current reserves. And then we have enhanced oil discoveries. Those would be potential reserves. And then we see non-conventional oil. So we can see the importance of new discoveries. We can see the importance of using the potential reserves and then other non-conventional oil, such as like biofuel. Coal production is highest in both the United States and China. Crude production is highest in Saudi Arabia and Russia. We look at natural gas, again, reserves in Russia and the United States. Natural gas in the United States is mostly used for heating houses. Coal is often used for heating large factories or buildings, skyscrapers. We look at the world coal reserves. When we look at the coal reserves, most is going to be found in developed countries for coal. When we look at natural gas, it's the opposite. Most is going to be found in less developed countries. And even more so when we look at petroleum. Most of the petroleum reserves are found in less developed countries. We look at energy consumption. Less developed countries are forecasted to use more of the non-renewable energy into the future. And again, the importance in our future of using alternative energy or renewable energy. We can look at the price per gallon as well. We can see the increase of petroleum. The sources of petroleum, U.S. Domestically in 1973, we produced most of our oil, and then in 2009 we produced less, and then 2020 would be a slight uptick in domestic production, but still the most of the oil production is going to be found in LDCs, with the largest country of LDCs being mostly OPEC countries that are found in the blue. Barrels production. We look at energy usage and how we use our energy. The most energy we use is in agriculture for fertilizers and irrigation. The second most we look at energy is the overall distribution of moving consumer goods. The third most is seen with natural gas and the heating of our houses. Why are resources being depleted? Minerals are non-metallic. Those are often used in fertilizers or agricultural production, such as phosphorus or sulfur and potassium. There's also the importance of calcium. Metallic they're either ferrous. When they're ferrous, they can combine iron with the oxidation process, forming steel, and other ferrous metals such as iron ore, nickel, tin, titanium, and tungsten. Non-ferrous, they cannot be combined to make a harder, more durable form of metal structure. Aluminum comes from bauxite. It's virtually inexhaustible. Copper, lead, magnesium, and zinc are also non-ferrous. And then precious metals are non-ferrous. Again, they cannot be combined with iron to form steel and cannot be further processed into harder forms of metal. Elements of the Earth's crust. We can see oxygen makes up about 46%. Silicon, about 1/4%. Minerals as they're distributed around the world. What are ways that humans are impacting the environment? Well, 3 ways in pollution: air, water, and land. Air pollution on a global scale, we see global warming. On a regional scale, we see acid precipitation. On a local scale, we see urban pollution and respiratory challenges. And if you think about when the weather warms up, in the Twin Cities area, they'll always issue an air pollution warning for those that have respiratory issues or elderly. Water pollution, there's usually there's source pollution, water source pollution, which we know where it's coming from, such as industries, so it's easier to stop. Industries also can use municipal sewage, especially in suburbia. Most they're going to be municipalities where their sewage will go to a drainage field or a drainage tank. Agriculture is the most difficult form. It's a non-point water solution. Agriculture from large industrial farms, commercial farms. Again, very difficult with how large these farms are to track and eliminate the pollution of runoff of fertilizers, which creates the eutrophication process. And then there's land pollution, and that comes from waste, human waste. Solid waste accounts for over half, is found in landfills, sanitary landfills. Some is incinerated. Incinerators burn, but with incinerators it provides energy, which is positive for local businesses that tap into that industry or residents, but it also creates emissions into the air, increases carbon emissions. Recycling is another way to eradicate land pollution. Then we also have toxic waste, hazard waste, toxins that come from motors and vehicles and other engines, and hazard waste from nuclear waste as well. Global air temperatures, we've seen it increase in this particular line chart since the 1880s. We can see carbon emissions has rapidly grown with industrialization as it's diffused around the world, and then the use of cars since the 1900s. We can see acid deposition and acid rain or precipitation affects the fifth largest cluster in the world, the largest population cluster in southeastern Canada. Okay, we can see acid precipitation in Mexico City on a local level, and it affects air quality for people with respiratory issues. We can see agriculture and how it, with the Aral Sea, much of the Aral Sea was designed to create cotton under the Soviet Union, and the need for cotton is of high demand. We can see how the Aral Sea has declined in size considerably. 8.2. Explain the various ways that humans impact their environment. I-CAN statement. Explain key benefits of the following renewable resources: solar, geothermal, wind, biomass, nuclear, not quite renewable, but like I said, alternative. Describe how sustainable land use is described through preservation and conservation efforts. And 3, explain the importance of using preservation or conservation with the biosphere of our Earth. Renewing energy. Nuclear energy. It's not exactly renewable, it's alternative, but a large amount of energy can be stored and used with a small amount of material. So it has a great return and yield compared to how much energy is used. Biomass, it comes from our biosphere, wood, crops, corn, the waste, and then they will burn that waste to provide energy. Example would be through corn, ethanol. Hydroelectric, again, water, wind, the harnessing of wind, and then geothermal, the energy from our Earth's sublayers below the crust, and then solar, the most widely used is the sun, and then recycling. All right, nuclear power, we can see it's commonly used in Europe. The most nuclear power is used in France. Uranium, which is a resource used for some forms of nuclear production through the fission process. We can see uranium is found almost evenly divided between more developed and low developed countries. We can see nuclear power is the highest arithmetic density and concentration is in the northeast. And then also we see clustering in Illinois. Hydroelectric energy is common in less developed regions of the world, as you can see in sub-Saharan Africa and South America. Wind power, most of our wind is harnessed in the west or through the plains of the U.S. Solid waste, we've seen the impact of recycling. However, we still see problem areas such as food waste and plastics and paper. Sustainable development, there are 2 ways to sustainably develop. One is conservation, to sustain the use of current resources and manage the current resources. And then preservation is the maintenance of resources in the present condition, oftentimes reducing the consumption of resources to provide more for the future. Biodiversity, scientists believe, is the most important to preserving the diversity of species on the Earth. micrograms of GDP per capita. As we see GDP per capita, as it increases, we see the microbiology decline.